Welcome, my dear NEET 2026 warriors. The class 12 syllabus is on full swing. We're already on the lecture number 2 of chapter 1 of 12th standard physics. And we are going to talk about electric fields due to charges and the electric field lines and their properties, but also superposition of electric fields. All of this in today's class with none other than your Captain Shreyas, your physics teacher, who has done his graduation from NIT Nagpur and research from ID Bombay. So take the full advantage of the best, master teachers that you have for physics, chemistry, biology in this particular series. Every day, 11 o'clock, 11th standard syllabus, and 8 o'clock, 12th standard syllabus. All right. So subscribe to the number one NEET English channel and also hit the like button for your Captain Shreyas Sir. Hi, Blessy Money. Welcome, Harini. Good evening, my dear students. I hope you guys are doing fabulous and all excited for the lecture. And let's also have a look at last time's students who answered our questions. Okay, so let's go back over here. And that was our first lecture, by the way. And kudos. And if you have not yet liked, please like the video. Session PDF is going to be available just like last time, even for this time, in the description box as well as in the pinned comments. You will see it over here. You click on it, the PDF will open up. Okay, so this is how the PDF will look like. Yeah, all that PDF with annotations, everything will be there. Okay, so very good, Kevin, Harshita, Sai, Chinni, welcome, Chinni, Akshita, Dharini, and Harni. Very good, very good. Keep it up. And I want more and more students participating in every session. Don't stay calm saying that, sir, maybe my answer is wrong. It's okay. Even if your answer is wrong, somebody will comment and explain you the answer. That's the best part. In Vedantu NEET English community, our members, our subscribers, they help each other. Even if you make some mistake, even if you give 100 wrong answers, nobody will judge you. In fact, those mistakes are what are going to build you. Okay. And those of you are also looking for offline batches, please remember that we have plenty of offline batches for NEET for 1 year, 2 year. And this year we had amazing results in JEE, even in Karnataka, even in Maharashtra, even in Tamil Nadu, everywhere, guys. All India rank 15 in JEE, by the way. NEET results we are awaiting. And we have centers everywhere, right from Tamil Nadu, Telangana, Delhi, Bihar, Odisha, Rajasthan, Maharashtra, Punjab, Andhra, Pondicherry, Uttar Pradesh, and the newest center in Karnataka in Bangalore, JP Nagar, right? And you can get up to 90% scholarship at any of these centers for any of these batches based on your test scores. So give that scholarship test, go to the center. You need to book your visit at the center by clicking on this link. Offline courses, book a visit now over here. You can enter your name, grade, phone number, etc. You can choose wherever you are from. Let's say you're from Pune, you're from Warangal, Tirupati, right, Madurai, Coimbatore, etc. Just book your slot and visit the center, right? Cool. So let's begin. Hi, Advika. Sir, when will the class 11 physics chapter? Class 11 physics chapter is starting tomorrow, I think, 6 o'clock. Yeah. All right. KN motivation. Yes. What is your request? Hi, Rehan. Hi, Tirtheshwara. Welcome, Resanti. Welcome, Kevin. Hi, good evening. Hello, Hari. Hari Hara. Will you complete this chapter? Yes, not today, but in multiple lectures. See, guys, there is a disadvantage of marathons that what happens after 3 hours, your mind gone. Teacher will also speed up. Ayo, Papa, students are only feeling sleepy. Okay, let me teach fast. Not just me, any teacher you see. Unless those lectures are like combined from one hour and you make a combined video. We want that same motivation, energy, enthusiasm, alertness, focus throughout the class. That's why if there is a chapter worth 8 hours of study, instead of taking it in one go, we are dividing it into one and a half hour or 2 hours classes. That way your energy levels are high, focus is there, and you will understand, or else you will miss out on all the other topics towards the middle or towards the end. Got it? Okay, that is the idea of these classes. Okay. So last lecture in the last session, or rather, I would say previously, we have seen that between two charges, between two charges, between two charges, something like this, Q1 and Q2 separated by a distance r, the force of attraction or repulsion, the force of attraction or repulsion is given by, you can write the constant as k or even 1 by 4 pi epsilon naught. Yeah, either this or this, and then you put Q1, Q2 divided by r square. This was your Coulomb's law, which we have studied in the previous lecture. The value of this Coulomb constant is nothing but 9 into 10 to the power 9 in SI units. You can use K or 1 by 4 pi epsilon or 9 into 10 to the power 9, and you multiply it by charges and divide it by the square of the distance between them. That was your electric force between two charges. Now comes the idea of this electric field. Okay. To understand this electric field, let me, first of all, start with the significance part of it. Let me start with the significance part of it. Just imagine there is a big gunda. Okay, this is like one big gunda. In your class also some bully will be there. This is one big gunda, guys. Okay, big gunda fellow only. This is your big gunda fellow. Okay, now imagine one small pavam fellow will come. One small pavam fellow will come. What will this gunda, rowdy fellow will do? This rowdy fellow will hit him. Dhup. One slap he gives, one box he gives, one kick he gives. He will start shouting at him. Full on rowdy fellow only. Okay. So there was a nice force acting. There was a nice force acting by this gunda fellow on this pavam pandu fellow. Okay. So now everybody is scared. So one day what happens? A new Pandu joins school or the class. He does not know who is Gunda, who is nice, who is bad, nothing he knows. So this Pavam Pandu, everybody tells, don't go near him. Don't go near him. Okay, don't go near him. So Pandu is scared. So this Pandu gets scared. Now, Pandu wants to know, really, is he that scary? So will this Pavam Pandu go near him? Will this Pavam Pandu go near him and get slapped? Get hit? No, right? Because Pavam Pandu is smart. What he will do? He will just go near him, but little bit far away, so that that Gunda fellow is able to see him. Maybe he's in a classroom. He'll just open the door and see. Slowly sneak and see. That Gunda fellow, whatever he was doing, he will look like this. He will give one killer look. That's it. This Pavam Pandu will get scared. Understood? But he will not get punched. The moment this Gunda fellow will give that killer look, this Pavam Pandu is going to close the door and run away. So what this Pavam Pandu is going to do, he is going to test. He is going to test whether actually he is a Gunda or not. Same way, things happen with electric charges. For example, imagine you had a charge. Imagine you had a charge, capital Q, and you actually had another charge, let's say small q over here. So this capital Q is like that Gunda fellow, and this small q is that Pavam Pandu. If they are in the vicinity of each other, at some distance r, 100% there will be a force on this guy. 100% there will be a force on this Pavam Pandu. So what if I want some quantity where I won't want to actually apply the force because of this Gunda fellow? I don't want the force because of this Gunda fellow, but I want to know what is the aura, what is the presence, what is the, effect that he carries, what is, that aura around him, is that craze around him, is he so scary, that thing I want to measure. Then I won't measure the force, I will call it as the field. In his field, what field does he carry? So this gunda, this charge q, will have some field, but for that field there need not be a charge. This field is anyways there. This gunda, wherever he is, he has his field around with him. He finds one pandu, dhab. He finds another pandu, dhab. He applies force. So field is there because of this guy, not because of this guy. When this Pavam Pandu comes in his field, in his territory, in his region, where his aura will be felt. Got it? Aura. You might have heard this word aura many times, the Gen Z word, right? When this Pavam Pandu comes in his region of field, he will experience that force. But if he's not, then this Gunda fellow, this capital Q charge, will always have something called as the field. For that field, you don't need that charge. You don't need that charge. You just need one single charge. A singular charge creates a field around it. Got my point? Yes, aura 999 plus, correct. Yes, Kevin, the previous answer 0. Yes, I am guessing I'm audible. Hi, Ravi, namaste. Yep. Tripura very soon. Resanti, I'm guessing you're from Tripura. Wow, wonderful. One day I want to visit all the northeastern states and have a nice trip, probably after the monsoon. I've heard a lot of stories and seen beautiful pictures. So, field is then defined as that force which acts on that Pavam Pandu, but per unit of that Pavam Pandu. Meaning, if you take 1 unit of that charge, how much force acts? So that is per unit test positive charge. Test positive charge. Force acting on a unit test positive charge is called as the electric field. This is not any field. This is your electric. This is called as your electric field. Electric field is how much force will a test charge. This Pandu was like a bakra who was meant to test. Oh, you bring that Pandu, thap, he experienced a force. Oh, how much force? Oh, what was your charge? So force per unit charge is basically the electric field. Why only positive? There is a simple reason for it. If it was negative, the force will change the direction. Even the field will be in the opposite direction. But remember, the field is only dependent on this guy, not on what you put for testing. So we define that, okay, for a positive charge, whatever is the field, if you know, for negative, it will be exactly opposite. So we made a convention, like a standard, or else everyone will be confused whether to take outside or this side, left or right. So we created a standard saying you always choose a Pandu who is positive to test. So then the force that will apply will give me per unit charge the electric field. Okay, so there is no confusion. Else somebody will take negative, the force will be in the opposite direction. So to maintain consistency, that's all. So can you guys now think that field, by the way, the symbol for that is E. What is the symbol for field? It is basically going to be E. So what will be the formula then? The formula for E will be nothing but the force per unit test charge. Per unit test charge. So E is equal to F by Q. That's it. So E will be equal to F by Q. This is the formula of electric field. E is equal to F by Q is the formula for electric field. This is the electric field due to capital Q charge. So just to come back and tell you, I can say that the electric field due to due to a system of charge or charges is the Coulomb force per Coulomb force per unit test positive charge, per unit test positive charge. So if you have some charges over here, and you bring a test positive charge, then whatever force acts on it per unit of that gives me the value of the electric field. So since electric field will have direction similar to that of the force, I can also call it as a vector quantity. So electric field is nothing but a vector quantity. It's a vector quantity, and the direction is same as the direction of the force on a positive test charge, on a positive test charge. So if you put a positive charge over here, whatever is the direction of that force, same is the direction of the field as given by the direction of the force. If you ask me the unit, it is very simple, guys. What is force measured in? Newtons. What is charge measured in? Coulombs. So it will be nothing but Newton per Coulomb. The Newton per Coulomb. That is the unit. Later on, you will also see there is another unit called as volt per meter. We will see the derivation or the significance later on, but just remember for it now. So Newton per Coulomb, the short form is N by C. Volt per meter, the short form will be V by M. N by C or V by M. Both are the units of your electric field. Everybody till this point absolutely clear? Let me know. Thank you, Tarnesh, for all the love from Tamil Nadu, and definitely we are not stopping this series. You know it from our last lecture, last year, sorry, RNA series, and before that Super 6 series. If you see other channels, I cannot guarantee you, but on our channel you might have seen the consistency and how we complete the series. Yeah. For now, this is very important. Fine, sir. Great. So, sir, can you tell me the electric field? Can you tell me the electric field due to a charge? Let me just get it over here. A second. Okay. So, can you tell me the value of the electric field due to a point charge? Due to a point charge. Can you tell me what is the value of the electric field due to a point charge? Whatever formula comes, you have to remember it. It's not that difficult. Let's say this is this charge q, and let's say our test charge small q is over here, and they both are separated by a distance of r. I want to find what is the electric field at this particular point. So all I need is the force acting on it, and if I divide by the charge, I will get the value of the field. So going by our formula, E is nothing but the force divided by the charge. But what is the charge? What is the force? What is the force? We already know it is Coulomb constant Q divided by R square. I just gave it to you at the start of the class. I told you this is what we have done in the previous lecture. Yeah. So basically it is nothing but KQQ divided by R square. That is the value of the force. Best part about this is that this Q and this Q will get cancelled. It should get cancelled because the field shouldn't depend on the test charge. It should only depend on the charge producing the field. So that is the charge capital Q which is producing the field. Hence, you will see that the electric field, hence you will see that the electric field formula magnitude wise is KQ divided by R square. That is the formula for the electric field due to a point charge. Due to a point charge. You can also see how the field varies with the distance. How the field varies with the distance. So on the horizontal axis, let's say that is the distance r, that is the distance r, and here on the y-axis we have the field strength, which is basically E, because you can see over here that the electric field is inversely related to r square, meaning when r increases, electric field decreases. When distance decreases, field increases. So the graph of it looks somewhat like this. It's a curve, it's not a parabola, hyperbola, ellipse, this, that, no bola or no circle, nothing like that. It is just a curve. As you can see, for smaller distance, the field is strong. For very large distance, the field becomes weaker, as expected. Everybody till this point absolutely clear? So KQ divided by the R square. Maybe we can look at a formula question based out of this right over here. Okay, the electric force experienced by a charge is this many Newton. Find the magnitude of the field at this position of the charge due to the source charges. Notice what and all is given. The electric force is these many newtons on the test charge, on a charge of these many coulombs. The question is, can you find the electric field at that location? We know electric field will be nothing but the force divided by the charge which is being put to test. Okay, so the force value is given as 25 into 10 to the power negative 3. The value of the charge being placed is 5 into 10 to the power negative 6. As you can see, 5 cancels with 25 5 times. This minus 6, let me bring it on the top. So this will become 5 into 10 to the power minus 3, 10 to the power plus 6. What is 6 minus 3? It is basically 3. So it will become 5 into 10 to the power 3. That is the electric field. What is the unit of electric field? I told you, Newton per Coulomb or volt per meter. Any one of them. So I can see 5 into 10 to the power 3 is there as option number A. Hence that is the correct answer. Is that right? Okay. All right. I'm so glad, Sai Nivas, that you sense the happiness when I solve physics. And it's not just solving physics, but also when I teach, I enjoy. Every year I do the same thing with the same enthusiasm, hopefully, because every year it's a new set of students, but you are learning physics from the scratch. And I want everyone to get that kind of motivation and that energy. All right. Fair enough. Let's say another question. Where is it? Let's say another question. Here is the question. Find the field due to a proton at a distance of 16 angstrom, or let's say, yeah, at a distance of 16 angstrom. That is the question. Let's try to solve this question, guys. Find the electric field due to a proton at a distance of 16 angstrom. So when you talk about a proton, obviously it is a positive charge, and this distance is 16 angstrom. And over here, you are interested to find out what is the electric field. Well, first of all, what is 16 angstrom? 16 angstrom is 16 into 10 to the power negative tens of a meter. If you ask me what is the charge on a proton, charge on a proton, it is nothing but positive E. We have seen this in the earlier part. Charges on proton is positive E, electron is negative E. So positive E means it will be nothing but 1.6 into 10 to the power negative 19 Coulomb. So if I want to find the electric field, this is a point charge, this is the distance. So for that, I just give you the formula. E is kq by r square. E is nothing but kq divided by r square, isn't it? So let's use that then. Kq by r square. K into q divided by r square. Is that right? Everyone with me on this? I'm so glad, Sai, you're saying that. I love physics because of you. I'm so glad. Please, I hope this kind of motivation and energy stays there. Okay, so already Kn dots already giving the answer. Wow, very good. So what is it? K value is 9 into 10 to the power 9. Q value is 1.6 into 10 to the power negative 19. R is 16 into 10 to the power negative 10, but do not forget to square it. Okay, so I have an idea. This plus 9 and minus 19 will go away. But before doing that, why not write this 1.6 as 16 and this is 10 to the power 9. And if I write it as 16, I have to increase that negativeness power. So it will become minus 20. So did you understand? I removed that decimal. So I have to put 10 raised to minus 20 on the top. Okay. So this is 16 square. So 16 multiplied by 16 and 10 raised to, this will become minus 20. Okay. Certain things definitely look that they are cancelling, like this one and this one, this 16 and this 16. So I am just left out with 9 by 16 into 10 to the power 9. But what is 9 by 16? You can just do the calculation, guys. Come on. How much is it? Already somebody has given the decimal value. Come on, guys. What is that decimal value going to be? Yep. Kn dot saying 0.56. Perfecto. Perfecto. Let's see. 16 and 9. 0.0. This is 5. This goes with 80. This is 10. And this is 6. Yes, 0.56 should be the answer, guys. 0.56 if you divide it into 10 to the power 9 Newton per Coulomb. That's a very strong electric field. It's huge. 10 to the power 9, guys. Yes, 0.56, 10 to the power 9. Very good. Very good. Very good. Excellent, Krutik and Arni, Sahiti. Very good. Very good. Now that we understand how do we find out the electric field, how do we find out the electric field due to a point charge? What if I give you another question kind of like this? Observe this now. Oops. Example. A field of 30 Newton per Coulomb acts on a charge of 0.25 Coulomb and mass a mass of 200 grams. Find its acceleration. Find its acceleration. That is the question. Let's see if you guys can figure this question. Find its acceleration. Well, if it is accelerating, there should be a force on it. So, who will give that force? This electric field. Do I know a formula which relates field and force? Of course, the definition. And it says that electric field is the force by the charge. So therefore, shouldn't the force be the field multiplied by the charge? The electric field multiplied by the charge. So think of it like this. You have a charge. You have a charge like this, and it is kept in some field, somebody's field. Because of that, it experiences some force. Because of that, it is experiencing some force. So we are first figuring out how much that force is, and that just came out to be E into Q. But we all know, but we all know by Newton's laws, by Newton's law of motion, this force, this force is mass into acceleration. So therefore, can I say m into a is nothing but, instead of force, you are putting ma is nothing but E multiplied by that particular charge. M into A is E multiplied by that particular charge. So my dear students, what am I going to get the acceleration as? I'm going to get it as the electric field multiplied by that charge, the whole thing divided by the mass. So EQ divided by M is the acceleration. Perfect. So let's figure it out now. Electric field value, I think it is given to me as 30. Is the charge given to me? Yes, as 0.25. Is the mass given to me? I think so. 200 grams is basically 0.2 kg. Yes, this 200 grams is nothing but 0.2 of a kg. Is that right? So that's how we are going to solve the question now. All right. So what and all will get cancelled? Nothing is going to get cancelled. No issues. Let's solve it normally. So acceleration will be, this 0 multiplies with this decimal. So it will become 3 multiplied by 2.5 divided by 0.2. Shift this decimal on numerator and denominator. So it will become 3 multiplied by 25, the whole thing divided by 2. Is that right, everyone? Very good. Oh no, it will not be in meters per second. Please be careful. Meters per second square. It is acceleration. So 3 into 25 is 75. So 75 by 2, my dear students, how much will it be? How much will it be? It will be 37.5 meters per second square. Yes, 37.5 meters per second square. Is that correct? Sai, you can put up such questions in the comment section, because I don't want to break the flow of the lecture. So, you know, those kind of doubts you can, because that's not relevant to today's class exactly, maybe. So just put it up. I'll definitely help you out. Okay. So the acceleration comes out to be 37.5 meters per second square. This is how you can solve these questions. I think I have kept a question somewhere on finding the acceleration, maybe. Yes, this was asked in NEET 2024. Check this out. A charged particle of mass m and charge q is released in a field E. Neglect the gravity. How much kinetic energy will it have after t time? Kinetic energy formula is half mv square. If I know speed, I can find it. But how do I find speed? Think reverse. Think reverse. For finding the value of kinetic energy, for finding the value of kinetic energy, I will use half mv square. Mass, I know guys, that's perfectly fine. But what is speed? That is the problem. If I know the speed, I can immediately get the value of kinetic energy. Oh, okay. So to find speed, I have an idea. If I somehow find acceleration, I can find the speed, because v is nothing but u plus acceleration multiplied by time. And what is the initial speed? Released from rest. That means it is 0. Oh, but wait a minute, sir. I don't know the acceleration, sir. If you tell me acceleration, I can tell you velocity. So it's like this guy is asking, hey, tell me the answer. That guy is telling you, tell me the answer. Now you have to ask somebody else. Who will tell me the acceleration? Okay, I know one guy. Electric field is force by charge. Therefore, force is field multiplied by charge. By Newton's law, just like we did in the previous question, force is mass into acceleration. So that is field multiplied by charge. Therefore, acceleration will be EQ divided by M. Yes, sir. We can figure out the acceleration. So that is why I say, before you go to PYQs, you should solve basic question. Like, for example, this one. Wasn't this a basic question. If you know how to solve this, then immediately maybe it would have clicked. Oh yes sir, this PYQ question, no, I can solve it if I know the acceleration and I know how to do it. I've done it before. So that is how you should solve PYQs. Never start with PYQs first. Always do basic questions first. Okay sir, this is charge multiplied by field divided by mass, sir. So how much is the velocity speed coming out to be? Q E T divided by m. Perfect. Put it over here. Q E T divided by m. So it will become Q square E square T square divided by m square. And over here I have m by 2. So what will cancel, my dear students? I think there is m over here and m over here cancelling out. So I am left with k is equal to q square e square t square and divided by 2 into m. Yes, so that is the answer, guys. E square q square t square divided by 2 into m. C option is the answer. Got it? How to solve the PYQ? Everyone? Yeah. Definitely, VA Kasirajan. I'll definitely put up a video for your strategy for getting full marks. By the way, we have a student this year who is going to imagine this crazy level of physics paper, a NEET student getting close to 170 marks, somewhere between 165, 160 marks to 170 marks already in physics. That too in this NEET paper, which was one of the toughest NEET paper ever, yeah, in the history. Okay, perfect. Yes, sir. So now I understood, sir, how force, field, and charge, how to deal with it. This is very, very clear. Okay, fine, sir. Now let us talk about electric field due to multiple charges. Not one charge, but multiple charges. Same thing we have dealt in forces, guys. So it should not be a big shocker to all of you. Imagine there is one charge Q1 over here. Okay, that charge at this particular point maybe gives rise to some field like this. Maybe now there is another charge over here. I can call it Q2, and maybe at that same location, it is going to give some another field, let's say E2, okay, in this particular direction. Okay, maybe there is another charge over here, or maybe some another charge over here, let's say I call it Q3. This charge at this point, this charge at this particular point might give some another field maybe like this, because it can be negative charge. So negative charge will give field like this, positive charge will give field in the other direction. So there are some charges, they are producing some fields. So like that, maybe there are n number of charges, and all these charges at this location are producing some amount of fields, E1, E2, E3, like that. So this is E1, let's say this is E2, let's say this is E3, let's say this, sorry, this is not E3, this is E3, and let's say this is En. So what is the net electric field at that point? So the net electric field is given by superpositioning vectorially the fields due to all the charges, Q1, Q2, Q3, like that. So you find the field due to first charge, find the field due to second charge, do the vector addition till the nth charge. Please understand, I'm putting vector symbol, that means vector addition. That will give you the net electric field at that point. This principle sometimes is also called as the superpositioning principle. What is this sometimes called? The superpositioning principle. Okay, so I'm just going to block this off for all of you. Superpositioning principle. Is this absolutely clear, everyone? Okay. Yes, definitely, Kasir Ranjan. I know the main thing is one thing is understanding the theory, but other thing is actually getting it right in the exam. And this 1-2 years, we are just going to focus only on that because we have to think eventually of the exam. So first, we are going to do the theory so pakka, conceptually strong. Guys, I'm going to tell you, I'm challenging this you. Okay, physics. If you want to learn it from me. First of all, when I wrote my JEE advanced exam, that is 20 years back, I got almost full marks in physics. Number one. Number two, I derived many of the formulas on my own when I was studying physics. Number three, when I teach it from the fundamentals, basics, so that you love the subject, not just this is formula, this is definition, or this is how it is. For a NEET student, whatever is required, I won't teach Olympiad level now because for NEET, whatever is required, that much only. But so that you will understand the concept and you will be able to apply it. So mainly problem solving you should be able to do, not mugging up theory, which is of no use. Okay? Yeah. Fine. Okay. So let's see how do we actually use this in some questions. Say for example, okay. Say for example, let's take maybe a triangle over here. Let's take a triangle over here. And let's say there is a charge Q. And let's say there is another charge over here, minus 2Q. And we want to figure out at this particular point, given that this side length is A, what is the field at that point? Find the field at the point which has been marked on that triangle vertex. Okay, let's start. First things first, this charge at this point will definitely give an electric field. Can you tell me which side, which direction approximately will it be? It's a positive charge. So if I put a positive test charge, they both will repel each other. So the repulsion will make this charge apply a force in this way, which will also be the direction of the field. Okay, so I will call that electric field E1. No doubt it will be K into Q divided by A square. Electric field due to a point charge. Okay, let's go to this guy. It's a negative charge. So at this point, if I put a positive charge, that positive charge will sense attraction. So there will be an attractive force over here. And that electric field will obviously be E2. How much will that value be? It will be magnitude wise K into 2Q divided by A square. That is the answer. Charge into Coulomb constant divided by the distance square. That is the value of the electric field. Do you understand why it is left side? Why it is this way? It's a negative charge. So if you put a positive test charge to test, this negative and positive will attract. So there is an attractive force. So whatever is the force direction, same direction the field will act. Okay. So basically this is the answer. But these are the two individual forces. Okay. Now I want to find the net field. How do I find the net field? By vector addition. If you look at it, these are the two vectors. I think the angle also you can make out. It is not that difficult. Let's see how many of you are able to spam the answer in the chat box. Come on, guys. How much is this angle? I want to see the answer in the chat box quickly. So I did my graduation from NIT Nagpur and research from IIT Bombay. Okay, this is 60 degree. Why? It's an equilateral triangle. All sides are equal. So 100%, if this is 60, this is 180. So from 180, you take out 60. How much will be remaining? So 180 minus 60, which is 120 degrees. Oh, yes, sir. 120 degrees, sir. Okay. So now, what will be the net force? Net vector. It will be the resultant of both of them, which will be probably like this in nature, which will probably be like this. So I'm just going to mark that as the net field. This is the net field. So I know the net electric field. I know that the net electric field is the vector sum of E1 and E2. But I am interested only in the magnitude for now. So the net magnitude will be, simply put, root of a square plus b square plus 2ab cos theta. And here the value of theta is nothing but 120 degrees. This is your vector addition formula. We have used it even some time back for forces, superpositioning. Yep, perfect. So now, what is E1, E2 and everything? So let's start substituting everything one by one. So it will be root of E1 square. Where is E1? E1 square. It will be k square q square by a raised to 4 plus E2 square. It will be 4 times, because 2 square is 4. 4 times k square q square divided by a square plus 2 into E1 E2. E1 is nothing but k q by a square. E2 is nothing but 2kq divided by a square multiplied by cos 120 is negative half. Yes, cos of 120 is negative half. Okay, so let's see what exactly happens. First of all, can you see k square, q square and a raised to 4 is there here also? Okay, very good. This 2 and this 2 just got cancelled out. You can see that this 2 and this 2 got cancelled out. Okay, so I am getting kq square by a raised to 4 plus 4 k square q square by a raised to 4. This is minus 2 times k square q square divided by a raised to 4. A square into a square is a raised to 4. K square q square, 2 is also there. This negative also came. This 2 just got cancelled. Okay, sir. Now what? Can you see I can take k square q square by a raised to 4 common? K square q square by a raised to 4 common, and I'm left with 1 plus 4 minus 2 over here. This thing under the root, what will it be? It will be k q by a square. Root of k square is k, root of q square is q, root of a raised to 4 is a square. And what is left inside? 1 plus 4 is 5. 5 minus 2 is basically the number 3. Hence, the answer to this will be kq root 3 divided by a square. That is your net field. That is the answer. kq root 3 by a square. Is that clear? Very good, K and DTS. Perfecto. Sir, can I use Engage A to Z for physics because I already have this, or JEE books for question solving or for concept clarity because I'm self-study person? Kasi Rajan, if you're a self-study person, then don't just stick to one book. I would advise you to have a PYQ book, have a NEET objective book, and for additional practice, sometimes you can do the COVID era JEE means PYQs, like from 2020 to 2025, whatever these last 5 years question papers from JEE means, you can do that. That is more than enough. Yeah. All right. Okay. Okay. So this is how you can apply superpositioning principle. Maybe we have a question on superpositioning. Let's have a look at it. Yes, we have. In fact, this question also. Let's solve this first. ABC is an equilateral triangle. Charges Q, Q, Q are placed on the vertices of the triangle. Then question is, what is the electric field intensity at point O? I think this one, everybody should spam the answer in the chat box. Ayo, Sai, so many questions you are asking. We'll conduct one interview one day, okay? So you come to Bangalore office, or I will only come to Chennai very soon. And that time I will call you. You only take my full interview. I'll give you. Okay, you ask me 20 questions. All right. Or maybe on YouTube someday when we have Q&A question class. Okay. Some motivation casual session surely we'll have. Think, guys, logically. Charges and the distances are same. Q, 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 R, R, R. That means the field magnitude is going to be the same. That means due to this charge, the field will be, let's say, here. Due to this charge, the field will be over here. Due to this charge, the field will be over here. This is, let's say, E. This is also E. This is also E. It is symmetrically distributed. There is symmetry in it. That means they will all end up cancelling out each other. And once they cancel out, you will see that the net electric field will be zero. They are equal. See guys, if we had like 4 or 5 electric fields, maybe it was a pentagon or a hexagon. If they're all equally distributed, they will all end up cancelling. So as long as they are symmetrically and equally distributed, they will all end up cancelling. Hence, the answer should be a big fat 0. Yeah, so answer is 0. Very good. Excellent. Option 3. Let's do another question which is going to come up on your screen. This one. This one. Yeah, let's see if you guys can do this. Two particles A and B which possess charges this and this are held at a distance of 20 centimeter. Locate the point where the net field is 0. These kind of questions are also very, very common. So let's first draw the system so that let's understand it. So we have basically 2 micro Coulomb and the separation distance is also given to me. It is 20 centimeter, meaning 0.2 meters. And then there is another charge over here, which is negative 4 micro Coulomb. Why micro? Because it is 10 to the power negative 6. Negative 6 is micro Coulomb. Now, because of both of them, somewhere the electric field will be 0. What is your guess? Just think logically. Just think logically. Where is your guess that the field will be 0? Is it in zone 1 or zone 2 or zone 3? That means here or here or here. Just think logically. Which side will the field be 0? Here or here or here? Okay. Come on, put up the answer in the chat box. Shinchan, I'm so glad you are a part of the DNA batch. Welcome to the DNA batch, and I'm so glad you have made that choice before it is too late. Yes, very good. Keep it up. Sai, you can come to the Bengaluru HSR office. Okay? So, but tell me, because I don't usually come to the office. I take the classes from home. Yeah. So, guys, let me tell you the answer. See, if I'm over here, this positive charge will give a field here. This negative charge will give a field here. Okay. If I'm somewhere in between, this positive charge will give a field like this. This negative charge will also give a field in the same direction. So 100% it won't cancel. It won't cancel. But if I'm here, this positive charge will give a field in this direction. This negative charge will give a field in this direction. Now, this place or this place, how do I choose? One option though has gone out. I mean, this middle region, the field can't be 0 because it won't cancel. They are both adding. Now see guys, this positive charge will give a field this way, but this distance is closer. This negative charge is very far, so the field will be weak. But because the magnitude of the charge is more, maybe it will compensate that distance. Getting my point? Distance wise, this is more, but charge wise also it's more. So maybe they will cancel over here. Maybe they will cancel over here. Now, if you look at this place, what will happen? This is a negative charge. So that will give a strong electric field this way. It will pull it. If you stand here, it will get pulled this way with this negative charge. You are close and this value is large. Due to this positive charge, it is small value and you are far away. It will be a small field. So they will not cancel again. They will not be able to cancel because one is big, one is small. So if at all they have to cancel out each other, it will be somewhere here. Did you understand why this vector is big? Because the charge, there is more charge and it is closer, and it is closer. That's why it was big. The moment you are having a smaller charge, you are having a smaller charge, and you are far away, it is going to be a smaller field. So a big vector and a small vector will never be able to cancel out each other. Got it? Okay, very good. So now proceeding with the problem, let me assume a point somewhere over here at a distance of x meters where the field is 0. So what will happen? Due to this guy, the field will be here. Let's say I call it E2. And due to this guy, the field will be here. Let's say I call it E4. So that the net field is 0. Net field is 0. E2 cancels by magnitude the value of E4 because the net electric field is 0. That is the question itself. So the magnitude of E2 should be the magnitude of E4. As simple as that. The magnitude of E2 should be the magnitude of E4. So how much is E2? Coulomb constant, and you have 2 micro divided by r square. Here r is basically x. So put x square over here equal to E4 due to that charge. Coulomb constant, charge value is 4 micro. Do not put minus because we are just comparing magnitudes. You can see mod symbol. But what is the distance? Be careful, guys. See, from 2 you are at a distance of x. But from this guy you are at a distance of x plus 0.2 meters. So it is slightly different. So hence, do not forget to put x plus 0.2 whole square. Perfect. Now what happens is this k and k cancels. Even this micro will cancel. Yes, even this micro will cancel. Even this 2 will cancel with this 4 becomes this 2. Okay. So I am left with 1 by x square is 2 divided by x plus 0.2 whole square. Now cross multiply, you will get x plus 0.2 whole square is 2 times of x square. Take square roots on both the sides. Take square roots on both the sides. You will get x plus 0.2 is nothing but root 2 times of x. So what will you do? Take that x on this side. So therefore 0.2 will be root 2x minus x. Therefore 0.2 will be x common root 2 minus 1. Therefore x will be 0.2 divided by root 2 minus 1. Root 2 value is 1.4, so minus 1. That will be 0.2 divided by basically 0.4. Is that right? Is that right? So, by the way, this value was approximate. I did not calculate the exact value. This was actually 1.414. I made it approximate. This is as good as saying 2 by 4, which is 1 by 2, which is nothing but 0.5 meters, which is almost approximately 50 centimeters. Close to 50 centimeters. Which is the answer closest to 50 centimeters? 48.3. Hence, that is the answer. Got it? How do we solve it? How we have solved? Understood, everyone? Perfecto. Perfecto. Amazing. Amazing. Okay. Such a beautiful question. And how we have solved it step by step. If you solve like that in the exam, no way you will make any mistake, silly mistake, conceptual calculation, any stupid mistake. Nothing will happen. Okay. So always do step by step as I am doing. Okay, perfect. Do I have any other question? Yes, I have a NEET question of 2022. This is beautiful question. See guys, observe this. There are 12 positive charges, each same magnitude, in a circle of radius r in a manner that they are equally spaced. Okay, so let's visualize it because or else you will get confused. So just like the hands of a clock, let's draw it. 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7, 8, 9, 10, 11 and 12. So 12 charges are there, okay? Equally spaced. A charge capital Q is placed at the center. So each one of them is basically small q. Okay. And you are placing a charge capital Q at the center. If one of the charge is removed, then find the force on Q. Very beautiful question. Wow, Sai, if you are in 11th and you are able to understand, that's amazing. And considering the fact that you might not have studied vectors, Newton's laws, work energy, that's good. Because all those concepts at the back of the mind, we are using it. Maybe I'm not saying it, but you can see a lot of vectors concept, what is unit and dimension and Newton's laws. All these things are going to be useful. Anyways, so let's see how do we solve this. See guys, if you remove one charge, let's say for example, this was the question, right? So let me just duplicate it. Let's say we get rid of one of the charges, maybe this guy. What happens? Still, see, one thing is there. This guy and this guy together, if this guy gives a field here, this guy will give a field here. They will cancel. So this guy's field and this guy's field will cancel. Same thing. See, even I can say this guy's field and this guy's field. If this is giving field here, this will give field here. Equal and opposite, they will cancel. Even this and this will cancel. Even this and this will cancel. Even this and this will cancel. But the only thing which will not cancel is this. This charge is still remaining. There is a vacant charge. There is a vacancy. Something was removed. This was removed. Yes, you have removed it. So only the force because of these two charges are there. So right now they are in a circle of radius r. They are in a circle of radius r. So the question was, what is the force? So the force on it will be very simple. It will be K capital Q small q divided by r square. So KQQ by r square, K value we all know is 1 by 4 pi epsilon naught, and this QQ is there and this r square is also there. So KQQ by r square, not 11 or this, towards the position of the removed charge. Yes, towards the position of the removed charge. As you can see, this force, where is it directed? It is directed towards wherever you have removed it. Can you see that? Not away from it. Not away from it. It is towards positive charge, and yes, so that is the answer, towards the position of the removed charge. Not B. Not B. Lot of you said away from the position of the removed charge. Away means this. It's away. You had removed this charge, so you can see the force between these two charges will be repulsive. They will repel each other. So that is why it will be towards the removed charge, not away from it. Yeah? Cool? Clear? Shall we proceed ahead to the next? Okay. Going back now. Going back. So you have studied what is electric field due to a point charge, due to multiple charges, and so on and so forth. By the way, there is one formula which you should know. That is, if you have a ring-like structure, imagine a charged ring. If you have a charged ring, let's say the charge on it is Q, and let's say the radius of such a ring is assumed to be R, and if you are at some distance of x from it, at a distance of x from it, and here I want to find what is the field. See, I'll tell you the logic behind it. Need not have to go by the derivation and all of that, but just I'll tell you. See, imagine that ring. It is made up of multiple charges. Multiple charges. If you consider a small charge over here, I call it dq. That dq charge, okay, that dq charge at this place will give a electric field like this. That dq charge at this place will give an electric field like this. How much will that field be? Well, I need this distance. How much is this distance? By Pythagoras theorem, it will be r square plus x square, the whole thing under the root, this hypotenuse distance. So this small electric field dE will be Coulomb constant into dq divided by this distance, whatever is there, r square plus x square whole square, right? Kq by r square. Why dq? dq is a small charge at the top. Now think again about another equal charge which will be present exactly opposite over here, and that is also at the same distance from this point, and that will also give the same amount of electric field over here, which will be basically dE. Oh, so what are you trying to say, sir? See, my point is each of this dE which is there, that will have two components. Components are basically parts of a vector. So one component here and the other component over here. Same thing for this guy. This electric field over here has one component in the horizontal direction and the other component in the vertical direction. Can you see what will happen? Which component will add? Which component will subtract? Can you see the ones in the y direction are going to cancel? Yes, this is the d is y component. This is also the d is y component. Both of them are like this. They will add to go like that, but their vertical components, their y components cancel out each other. But it is only their x components which add. Dex and Dex. These components, the x components will add. That is what will be remaining. Nothing else will be remaining. They will add up. Is that clear, everyone? Very good. Now, this is not just true about these two charges, but any two diametrically opposite charge. So, this is true. This is for all the charges and their opposite charge along the diameter, if you do that. So if I try to find the net field over here, when I try to find the net field over here, can you guess what will it be? Can you guess what will it be? It will be the sum. Oops. It will be basically this. When I try to find the net field, this field, the net field is the sum of all the x components of the fields due to dq charge. Sum of all the x components, not the y components, only the x components will add. And whenever you have sum, it means you have basically what? Integration. Whenever you have sum, you have basically integration. So it is basically integration of this x components. That's all. It is just the integration of this x components. And you can very easily find out the x component. It is not that difficult. You will have to basically say that, you know what, this is basically, let's say, theta. So even this angle is basically theta. Okay, so dex, you can find it out saying it is nothing but d is cos theta, because this, if it is theta, this is the cos component. So de cos theta. D value I just told you, it is k into dq, the whole thing divided by r square plus x square, because root and square will cancel, multiplied by cos theta. What is cos theta? Adjacent side by hypotenuse. So adjacent side is x, hypotenuse is root of r square plus x square. So when you substitute this value, when you substitute this particular value over here, when you substitute this particular value over here, you will get the integral. So it is not that big a deal, even if you try to do it. So integration of, just try to put this entire value, guys. This k dq x divided by r square plus x square, the whole thing into root of r square plus x square. You will see x is actually a constant. Don't get scared. X is same. No matter which charge you take, all the charges, x value is the same. So you will notice that most of the things will come outside, like k, even x, even r square plus x square. Root of r square plus x square is r square plus x square raised to 1 by 2. The only thing which remains inside that integration is just integral of dq. Don't worry, what is that integral of dq? I'll tell you in the next step. So this is kx. And what is this r square plus x square? Raised to 1, and this is raised to half. So what will it become? R square plus x square whole raised to 1 plus half. And what is integration of dq? It means adding all the charges. Adding all the charges. That's it. It is basically q. Add all the charges on the ring. If you add all the charges on the ring, you will get basically the total charge. What is 1 plus half? 3 by 2, right? Hence, the answer to this particular question comes out as k q divided by, and x is also there, sorry. This k is there, this q is there, this x is there, and the whole thing divided by, you have r square plus x square raised to 3 by 2. R square plus x square raised to 3 by 2. This is very, very important. Okay. So remember this form. Okay. So kqx divided by r square plus x square raised to 3 by 2. R square plus x square raised to 3 by 2 has come because of this. 1 plus half is 3 by 2. Okay. So this is very, very important. Keep this in mind. I'm blocking this for you. Cool. Everyone? Awesome. 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 Perfect. Now, let's go to the final part, which is basically electric field lines. When you have played with magnets in school, you might have put some iron filings on it and you would have tapped it and you would have seen some beautiful patterns formed around the bar magnets. These are basically your magnetic field lines. Magnets produce magnetic field lines around it. These are basically magnets. These are nothing but magnets. So similarly, if you have charges, electrical charges, what will they produce around them? They will produce electric field lines around them. These are called as electric field lines. They are very much similar to magnetic field lines except for one or two things, but other than that, they are all similar. So what is the meaning of electric field line? Okay, let's understand it. Say for example, I take a positive charge. I have taken a positive charge. Imagine I am at some distance from it, and no matter where I go at the same distance, the field will be the same. No matter where I go at the same distance on a circle, if R is same, the field will be the same. So everywhere over here, I will get some value of the field, electric field, like this, like this, like this, like this, like this. Why is it outwards? Because for electric field, you always test it with a positive charge. So if I put a positive charge here, they will repel. If I put a positive here, it will repel. Positive here, repel. Positive here, repel. So that's why it is outward. Say for example, I go at a slightly far away distance, maybe over here. Okay, just imagine I go at a slightly more distance, maybe over here, like this. So I'm taking some other distance now. Oops. So I'm going at some more distance. At all these points, because R is same, the magnitude of the field will be the same. And you will see maybe the field will not be as strong as before, but it will be there in equal amounts. So maybe it will be like this, maybe like this, maybe like this, maybe like this, maybe like this, and like this, and like this. Now you can keep on drawing more such things, but the point that I wanted to convey is this, that if you have some kind of a charge here, I can continuously make such lines, which is of electric field, like the one here also. I can keep on going from here to here to here to here like this. If I join that, join that, join this, sorry, join this. These are called as the electric field lines. These are called as the electric field lines. So the electric field lines give you an idea of how the electric field is traveling around those charges. For a positive charge, it is radially outwards. So for a positive charge, the field lines are radially outwards. They are radially outwards. But if you take, for example, a negative charge over here, something like this, you will see that the electric field will be towards it, because if you put a positive charge, it will get attracted. So the electric field lines are going to look like this. In fact, that also becomes the general rule. So for a negative charge, the field is radially inwards. The field is radially inwards. The field is radially inwards. In fact, that also becomes a general rule now. If you have one positive and one negative, how will it look like? Both of them are there together. It will look something like this. It's beautiful. Look at it. From positive, it is coming and it is ending on to the negative charge. From positive, it is coming and it is ending on to the negative charge. So this is always true. So field lines, electric field lines, electric field lines, they will always originate from a positive charge, and they will always terminate, you will see they will always terminate on a negative charge. They will always originate from a positive and terminate on a negative charge. And if you talk in general about electric field lines, so basically the electric field lines, what do? They give an idea. They give an idea of the lines of force per unit charge. So if I find some electric field line like this, if this is a field line, and then I draw a tangent to it, this is also very important, then the field at that particular point is always going to be, the field at that particular point will always be along the tangent. So the field vector is always along the tangent to the field, tangent to the field line. This also means that if I have two electric field lines, by chance they intersect. This is the point of intersection. Point of intersection. Then there is a new problem which comes, because then I will have two tangents. One tangent like this and another tangent like this. So once you have two tangents, it creates a new problem. It means there are two directions for the field. How can this happen? How can a field be in two directions at the same time? It is not possible. So that is why this is not possible. You should always have a unique direction. Only unique directions are allowed. Direction should be unique. It can't be ambiguous. It can't be this or that. You can't be like both are there together. No, it can't be. Either it is this or that. So that ambiguity can't be there. So point of intersection can't happen. Is that right, everyone? You will also see one more thing. Whether positive or negative doesn't matter. When you are close by, the field is strong. When you are away, field is weak. That also is seen over here. When the lines are close, the field is strong. When the lines are far away from each other, then the field is weak. So that brings me to the next property. That brings me to the next property, my dear students, that whenever you have electric field lines like this, okay, these are your field lines. This type of field, by the way, is called also as the non-uniform field. Non-uniform field, because you will see that at this particular place, the field is going to be strong. And the reason for that, the lines are closer. The lines are closer. Whereas here, the field is going to be weak because the lines are far away from each other. The lines are far away from each other. There are certain situations where the field lines are equally spaced. Then it is said to be uniform field. Then it is said to be uniform field. Something like this. Look at that. Now the lines are equally separated from each other. There is no strong or weak. Everywhere the field strength is same. So in such a situation, the field value vector wise or magnitude wise, it's the same. So E bar is basically constant. In such a case, it is said to be uniform electric field. Now you can have multiple charges and see how the electric field lines look like. For example, I have this simulation over here. Let's say I bring a positive charge. You can see how the electric field is because of that. The place where it is brighter, the field is strong. As you go far away, it becomes faint because the intensity of it reduces. Makes sense. Now you can see because it's a positive charge, it is radially outwards. The moment I will bring a negative charge, there you go. It is inwards. You can see that the field is inwards. I can move that charge here and there, and you can see how the field is changing. Now the field is concentrated here. If I bring the charge here, you can see the field is concentrated here. Is that right? So what will happen if I bring two positive charges together? So this is one positive charge. Maybe I'll put it over here. Okay, something like this. And I'll put one more positive charge over here. Oh my God, this is crazy. See how the field is acting because of both the charges. It's going like this. It will not intersect. It will come close and it will go away. It will come close and it will go away. But instead, if I put a negative charge, see how will it act? The field is coming from here and going here. Coming from here and going here. Yeah. If you want, I can change the magnitude of the charge also. Yeah. And now it is more positive. You can see. I'm adding more positive. So this is stronger. So this guy has more strength because there is more positiveness here. So you can see a lot of brightness over here. Yeah, but this is a negative charge. You can see it is not as bright as this one. It's very intense over here. So this is how electric fields can act. You can place these charges at different places and you can have a lot of fun, and you can see how the electric fields will change. Yeah, so let's say like this. So two positives and a negative. You can see it always starts from the positive and goes on to the negative charge. So this is what electric field lines do. They give us an idea of how the forces are acting, in which direction are they acting, and all of that. Isn't it fascinating, guys? Yeah, very good, excellent. So let's see some questions based out of that. And I think we have over here, which of the following statements about electric field lines is incorrect? Electric field lines never cross each other. Electric field lines do not form closed loops. Electric field lines cannot be taken as continuous curves. Electric field lines start from positive and end on a negative. Which of the following statements is incorrect? Is incorrect. Yeah. Come on, guys. Very simple. Answer is, yep. Very good. C. See, guys, they will never intersect each other. We just saw that. This is definitely not possible. This is not possible. This is not possible. We have seen that. Also, we have seen that if you have a positive charge and obviously a negative charge, electric field will start from a point and go to that point. It is not a closed loop, meaning it will never be like this. This is also not possible. Electric field lines start from positive and end at negative. What about the C statement? Electric field lines cannot be taken as continuous curves. It has to be taken as continuous curves. You cannot have discontinuous curves like this. Means imagine electric field like this, suddenly going away and then coming and then suddenly going like this. This is not continuous. Electric field lines will be continuous. It will not have breaks in between. Yeah, so option C, very good. Perfecto. Amazing. Okay, so now I have one more question, but this question I will keep it as homework. This question basically is your homework question, and you will be answering the question. You will be answering the question in the comments. I want the answer in the comment section. Okay, I want the answer in the comment section, everyone. So I'll give a hint. Basically, which particle has the highest charge to mass ratio? Forget about charge to mass ratio. Remember that concept which I told you, where if there is a field, there will be a force, and because of the force, there will be acceleration, and because of that acceleration, that particle will be pushed in some way. So what is the formula for acceleration? Just try to think about it. Acceleration was charge into the field divided by mass. So can you see Q by M over here? Can you see Q by M over here? Q by M into E. That's it. Immediately you will be able to see now how we can judge who has more charge by mass ratio. Okay. Answer will be there in the comments. Yeah. Okay. Perfect. So answer will be there, should be there in the comments. And obviously I'll share the PDF with all of you so that you will be able to see the solution itself. So I hope you learned a lot from today's session. It was a very intense session on electric field, field strength, field lines, fields due to multiple charges, field due to a ring and a point charge, all of this. So, after this, we'll be moving to energy and potential. Okay. And then we'll go to dipoles and then one last class, and then this chapter is over. It's a big, Gauss law is also there, and Gauss law and its applications, and then the chapter will be over. Okay. It's a big chapter. It will take around 5-6 classes. So stay tuned. Okay. Bye-bye. Take care.